All right, we're still on chapter 3. This is section 3.4. This is on energy. We'll talk a lot about energy throughout the year. So this is sort of your introduction to the idea of energy in chemistry as opposed to energy in physics. So as you know, energy is required to do work, and it's often defined as the ability to do work. Now, there are two types of energy that we deal with. Kinetic energy, which you guys know that's energy of motion. And here for us, we're going to be mainly talking about particles that are moving. Okay, so energy of the particles that are moving. Then there is potential energy, and there's positional potential energy, which we have, but what we mainly talk about is chemical composition. And so this is maybe like the energy that's stored in a chemical bond. And we often talk about stability in energy. So one thing that you'll want to keep in mind is that the lower the energy, the more stable it is. The lower the energy, the more stable. So we'll see that theme throughout all of this chemistry class here. The lower the energy, the more stable. We never lose energy, just like mass. We never lose mass either. Let's talk specifically about heat. Heat is caused by the motion of particles. When you measure the temperature of something, you're actually measuring a transfer of energy. And so if you're measuring something that's colder than the thermometer is going to transfer energy to that system. And vice versa, if you're measuring something that's warmer than the thermometer, then that system is going to transfer energy to the thermometer. So if you see here, objects, why do objects feel cold? Like if you put your hand, if you're sitting at a large table, the table may actually feel cold, when in actuality the table's room temperature, right? Because it has to be. Well, the reason why objects may feel cold is because their particles are moving slower than the particles in your finger. Now with the table, it's more about the transfer, how quickly it can transfer that energy. So what happens is when you touch something cold, like this weird ice cube. What did I do? When you touch something cold, so here's an ice cube, and here's your little finger. Fingernail. Oh, you're touching it. So there's your finger. Sorry about that. What's happening? Well, energy is flowing from your finger to the ice cube, because it always flows from high energy to low energy. Like you never put a spoon into boiling water. The spoon is going to get hot, right? The metal spoon, because it flows from high energy to low energy. That's just how it's distributed. So in this case, your finger is high energy, and then the ice is low energy. And so energy is going to be transferred. And that's why your finger feels cold, because it's losing energy. Now you can get burned, right? You can get a burn from, let's say, dry ice, which you guys know that's just solid carbon dioxide. So why can you get burned? I mean, this is super cold. The reason why you get burned is because a burn is essentially a very fast transfer of energy. And so this dry ice is going to transfer energy very quickly from your finger. Again, I don't know what I drew there. It's supposed to be a finger. Imagine a finger. All right? So we'll see transfer of energy again all the way throughout. And this chapter particularly deals with energy transfer coming up in the next couple sections. So we typically talk about energy in terms of joules. Right? So here is 1 calorie is 4.184 joules. I believe that's given to you on your pink sheet. And then we also have, in this case, video problem 4, where I show you how to do some conversions between joules and calories. Nothing huge. Now, just to let you know, the calorie that you think of for nutrition labels, so that's 1 capital C calorie. Well, a capital C calorie is basically a kilocalorie. Okay? Just remember, joules or calories. We this entire year we'll use joules. We don't really use calories.